Hi everyone, today we want to learn mapping the soil salinity with the Sentinel-2 satellite. Soil salinity is a critical factor affecting agriculture, particularly in arid and semi-arid regions like the Nile Delta, and high level of a soil salinity can impair crop growth and reduce soil fertility and hinder sustainable agriculture practice. Monitoring soil salinity can help with the land management decisions and identifying the areas where salinity is problematic and enabling intervention like the salt toleration on the crops or improve the irrigation practices. In this approach, we use Sentinel-2 Surface Reflectance data from ESA to assess soil salinity using the proxy known as the Soil Salinity Index or SI. This index uses two short infrared or SWIR and near infrared band to identify areas with high salinity as they tend to reflect the light differently from healthy vegetation. In a theory, the soil salinity index is calculated using the formula of a SWIR subtract near infrared divided SWIR plus near infrared and SWIR band 11, the shortwave infrared band, which is sensitive to the moisture content in the soil, and near infrared band 8, used to detect the healthy vegetation and its reflectance. A positive SI value, such as the high salinity levels, will a lower SI indicate healthier lands. This method is effective as a large-scale monitoring, especially in arid regions where ground-based salinity data is sparse. In a step-by-step implementation, here is a guide. First of all, define the area of interest. We selected the Nile data region. If you don't know how to calculate the bounding mass, you can watch the later video. And we zoom on Egypt, Cairo areas, and after the defining area of interest using the bounding box with the coordinates in the first longitude and latitude, and the map center object function center to map view of the specific area. And after this, we need to define the range. I selected the 2024 to capture the image in this range, and after this, we need to load the Sentinel-2 data. We load the Sentinel-2 data for the defined area of interest and filter the cloud cover below 20%, and then median composite is created to remove the temporal noise and provides a cleaner representation. And the filter bounds function restricts the collection to the defined area. The filter data function limit the image to those captured within a specific data range. And filter applies to the cloud coverage filter to reduce cloud interference. And the median generate the median composite, which helps to reduce the impact of clouds and other transient features. And the clip ensures the analysis only to cover the area of interest. After this, we can calculate the soil salinity index or SI. We defined this with the SWIR band 11 and near infrared band 8 from the Sentinel-2 imagery. And we calculate the soil salinity index using the normalized difference formula, and normalized difference calculate the difference between the SWIR and near infrared band to create the soil salinity index. And after this, we want to add the two color composite, and we use it the red band 4, green band 3, and blue band 2 to help to visualize the area in the natural colors. This composite is used for better visualization interpretation of the landscape. And in the next step, we define the visualization parameter. We define how to visualize soil salinity index to color composite on a map using the color palettes. And we use it for soil salinity index. We use the palette of lime green for healthy areas, yellow for moderate salinity, and red for high salinity. And for true color composite, the visualization use value between 0 to 3000 to render natural colors. And the final step is adding the layer on the map. At this step, overlay the soil salinity index and two color image on the map, and allowing us to visually analyze the salinity in the landscape. If we run this code, you can see we have a two layers, two color and soil salinity. The lime green area showing the healthy shows the healthy vegetation, and yellow and red showing the higher soil areas, and green shows the lower soil areas. If we load the two color composite, you can see we have an agriculture area here, and soil salinity is lower for these areas, but this areas is not a agriculture and vegetation areas, and we have a desert areas, and we have a more soil salinity index with the color of a yellow and red. You can use this for the any area of interest. We define it the data and range, and if you're interested using this, you can watch the video about the soil salinity from the Landsat and Moody's. So we utilize the soil salinity index to map soil salinity and display the soil salinity index, and with the two color composite to better visualize the landscape. And this technique can help in agriculture monitoring, land management, and water resource management in a region with the potential soil salinity issues. Thank you for your watching. Please subscribe and like our channels.